So welcome for theory of computation subject. First of all, we discuss about the unit 1 for the deterministic finite automata. And Dr.P.Ezhumalai, Professor and Head CS Department, R.M.D.E.C College. Deterministic finite automata. What is define the deterministic finite automata? DFA is a collection of 5 tables, same as we described in the definition of finite automata. The mapping function or transaction function denoted by delta. Two parameters are passed this function. One is the current state, another is the current input. The transition function determines the state which can be called as a next state. Example 1. Design a finite automata which accepts only the input 1, 0, 1 over the input set z equals 0, 1. They are going to design the finite automata for the accepting the input 1, 0, 1 for the given input set 0, 1. This is the finite automata accepting the input 1. The first Q0 starts from the Q0 state. We are giving input 1, it goes to Q1. Again, we are giving input 0, it goes to Q1 to Q2 for the input 0, Q2 to Q3, input 1. So when I reaching starting is Q0 and ending is Q3 with the input of 1, 0, 1. So we consider this input is accepted by the finite automata. The input set is 0, 1 only. Example 2. Design a finite automata which checks whether the given binary is even or not. This is the two states, Q1 and Q2. If we are giving 0, it goes to Q2. If we are giving 1, it goes to Q1. So again, if we are giving 1 in the input in the Q1, it goes to Q1 only. If we are giving 0 in the Q2, it goes to Q2 only. So if any number is even, this input will be accepted. 0, 2 0 is given. Okay, first 0 goes to Q1 to Q0. Again, we are giving 0, it will goes to Q2 only. The Q2 is accepting. 0, 0 accepted for the Q2. Similarly, if we are giving 1, Q1 will be sorted, not accepted. Even number of zeros. Example 3. Design a finite automata which accepts odd number of ones and any number of evens, any number of zeros. Let us see that. The Q S0 is the starting state. If we are giving 1 input, it goes to S1 to S0 to S1. S1 is the accepting state. If we are giving 0, so S1 to S1 will be repeated. Self-state, self-loop goes to S1 to S2 for the 0. Again, if we are giving 0 in the S0, it goes to S0 to S2. Again, if we are giving 0, it goes to S2 to S2 itself. So S2 to S1 to S2, if we are giving 1, it goes to S2. If we are giving 1 into S2, it goes to S1. So the input, when it is odd number of ones, it will be accepted. Even number of any number of zeros, any number of odd number of ones, any number of zeros. Suppose even number of ones you are giving means it will not accept it. It goes to S2. This is example of odd number of ones and even number of zeros. In design a finite automata to check whether the given binary number is divisible by 3. See that input is giving any number is divisible by 3, input will be accepted, input reached by the final state. It's not divisible by 3, the input is not reached the final state. So yes, we are giving, yes is the starting state. If we are giving input 0, it goes to S0. If we are giving again 0, it goes to S0 to S0. If we are giving 1 in the S0, it goes to S1. From the S1, if we are giving 1, it goes to S0. In the input 1, we are giving S, it goes to S1. So S1 to 0 means goes to S2. S2 to 0 means goes to S1. Similarly, S2 to 1 means S2 will go to. So what are the input you are giving? It is divisible 3 means it will reach the final state. So we conclude that this input, even number of any binary number is divisible 3, the input is accepted. It's not divisible 3, this input is not accepted. Example 5. Design a finite automata which accepts even number of zeros and even number of ones. Let us see that. This exam Q0 to Q1. If we are giving 0, 0, it goes to first 0 goes to Q1. Again, second 0 it goes to Q0. So the even number of 0 is accepted. Again, suppose the Q0. We are giving input 1, it goes to Q2. Again, 1 it comes to Q0. So this 0, 0 also accepted. 1, 1 also accepted. If we are giving 0, 1, 0, 1 like this. If we are giving 0 in the Q0, it goes to Q1. Again, you are giving 1 means it goes to Q3. Again, you are giving 0, it goes to Q2. Again, you are giving 1 means it goes to Q0. Q0 is the final state. So any number of even number of zeros and even number of ones also, this system will be accepted. Design a finite automata. The tree is the string made up of letters in the word, as I recognizing the string that contains the word cat as a substring. For the cat, we are going to draw the finite automata. So the first input Q0, we are giving C is an input. It goes to Q1. Again, we are giving self loop. It goes to C. We are giving A, it goes to Q0 to Q2. Again, you are giving T main, it goes to Q2 to Q3. The Q3 is the final state. So what is the input you are giving? There contains a substring cat means it is the final state. If it is not containing this in substring the cat, it not is the final state. So if any string you are giving, it contains a cat means it is the final state. This is example for the substring CAT. Example 7. Design a finite automata DFA for the following languages which is equal to Z equal to A plus B, Z equal to W. W does not contain any substring AB. The input string, you have to draw the, you have to get the input string. It contains A, B. That substring should not contain AB. For this finite automata, you have to design. This is a design for the example. If you are giving B, it goes to self loop for Q0 to Q0. If you are giving A, it goes to Q0 to Q1. Again, you are giving A means it goes to Q0 to Q1 to Q1 self loop. For being B means it goes to Q1 to Q2. So input will contains substring, contains AB, it reaches the not final state. It's not contain AB, it is the final state. So here the Q0 is the final state, Q1 is the final state. So the two final states are in the system. The substring which is not contain AB, it will reach the final state. If it contains AB, it will not reach the final state. Example 7. W contains neither substring AB or BA. This is a system for AB or BA. So Q0 is the final state. Here two final Q0 to the final state, Q1 is the final state, Q3 is the final state. We are giving B in the Q0 goes to Q1. Again, you are giving B self loop for Q1 to Q1 only. For giving A, it goes to Q2. In this side, we are giving B, it goes to Q0 to Q3. Q3 also final state. Again, A means it goes to Q3 to Q3. We are giving B means it goes to Q4. Q4 and Q2 is not a final state. Any input is giving AB as a substring. AB as a substring, it goes to final state. So BA, AB as a substring, A is the input goes to Q3. B as a substring goes to Q4. Q4 is a final state. So not final state. So AB string is not accepted. Suppose you are giving BA. So BA means two inputs, B and A. So B goes to Q0 to Q1, it's a B. Again, you are giving A means Q1 to Q3. So the Q2 is not final state. So B also not accepted. Thank you for listening this unit 1.